Hydrogen burns in air at temperature well above 100 degrees Celsius to form water. The boiling points of hydrogen and water are shown in figure 3. So you can see hydrogen has a boiling point of minus 253 and water 100, so much higher boiling point for water. Use this information to add the missing state symbols to the equation for the reaction taking place as hydrogen burns. So you can see that hydrogen burns in air at a temperature well above 100 degrees Celsius. So we know that the temperature we have to describe the states of these chemicals in is above 100 degrees Celsius. So hydrogen boils, it turns into a gas at minus 253. So we know that hydrogen must be a gas. Now water boils at 100 degrees, and if our temperature is greater than 100 degrees, then water must also be a gas. Very easy, really. Next, the atom economy for the reaction is 100%. State how the equation shows the atom economy is 100%. So atom economy really is taking into account how much useful product is made, or what proportion of useful product is made from the reactants you are reacting together. So if there are waste products made, then it will always be below 100%. But here we get 100% production of water, no other waste products at all. So no waste products produced. Think economy, you're saving money. So lead can be obtained by heating its oxide with carbon. The balanced equation for this reaction is as follows. Calculate the atom economy for the production of lead in this reaction. Give your answer to two significant figures. So firstly, acknowledge that we have a waste product here, so we know it's going to be less than 100%. Secondly, what this is asking you to do is we have a mass of chemicals here and a mass of chemicals produced here. This is the mass we're interested in. So what proportion of this is accounted for, or the mass of this is accounted for by the useful desired substance here? That's what we're trying to work out. So we start off by working out the combined mass of the reactants. So it tells you PbO is 223, but there's two lots of it, so it's 223 times 2. And 12, one lot of carbon. So the mass of the reactants is 458. Now, the mass of the useful product is lead, where you have two lots of lead. So lead is 207 Pb, and we have two lots of it. So it's 207 times 2, which is 414. So we're trying to work out what proportion as a percentage of 458 is 414. Okay. So 414 divided by 458 times 100 is 90% atom economy. So it's a pretty efficient reaction. You get a large proportion of what you make is useful, only a little bit of waste is produced. In an experiment to produce lead, 7.67 grams of lead are obtained. The theoretical yield of lead for the experiment is 11.8 grams. Calculate the percentage yield of the lead in this experiment. So this is just a simple percentage yield calculation, and you have the actual yield, what you actually get here, and you get here the theoretical yield, which is the maximum expected amount, or the maximum amount you can get over here. So percentage yield is simply actual yield, what you actually get, divided by the maximum expected amount, theoretical yield, as worked out by the formula mass. So actual yield divided by theoretical yield times 100 is percentage yield. So actual yield is 7.67 grams, as highlighted in the question in orange. And theoretical yield is 11.8 times by 100 is 65%. Next question. In most reactions, the percentage yield of any product is less than 100%. Give two reasons why the percentage yield is less than 100%. You just need to memorize the staple answers for this. Why don't you get complete success? Why don't you get everything you'd hope to get? Well, firstly, you get practical losses during the experiment. Maybe, for example, when you're transferring the material from the reacting chamber to how you're going to package it, some of it's stuck to the sides of the container. So that's what we call generally as practical losses. Other reasons are incomplete reaction. So maybe not all of the reactants actually react as desired, and some chemical reactions are reversible. So what might happen is the reactants react together, but then the reversible reaction happens as well, and they form their reactants again from the products. So these are common reasons I just remember. And whenever you get a percentage yield question, it's often always followed by reasons for why the percentage yield is lower than 100%, and so these always pair together.